Okay, so we're going to quickly run through this. I'm not going to be giving you like a full detailed workaround for every single question through the practice of Unit 1.2. This is the practice of Unit 1.2 with Pythagoras and the tangent ratio and slopes and grids and all that stuff. So I'm just going to quickly kind of whip through them here, go through, check what you need. So for question 2, calculate the angle of elevation and the slope of the hypotenuse here. So remember, angle of elevation, it's going to be this. It's asking for the theta of this, and then it also wants you to find the slope of the hypotenuse, which is this thing. That's it. It doesn't want you to find the hypotenuse, it wants you to find the slope of it. The slope is just equal to rise over run, right? Rise over run. In this case, the slope of this thing is going to be, the rise is 11 feet, the run is 25 feet. It's 11 over 25. To find this angle here, I'm going to, again, set up my equation. If you're using sides, which is the only things I know here, to find angles, you then need to use the tangent ratio. So tangent is equal to opposite over adjacent, right? If you ever forget this, remember, you can always do SOHCAHTOA. Tangent is opposite and adjacent. Okay, so then if I substitute this in, my opposite side, opposite of my angle is 11, and my adjacent, it has to be the 25 because this is the hypotenuse here, right? Because it's opposite of the right angle. Hypotenuse, opposite the right angle. Opposite angle is opposite of the angle that you're finding. That means this has to be the adjacent here. Okay, so I now need to, what I technically need to do is I need to divide by tangent, right? I can't do that, it breaks my calculator. So what I actually need to do is I need to have to pull up my calculator there. So I need to divide by 10 here. That doesn't work. So instead, I'm taking the second function, top left button on your calculator, click tangent. You're going to end up with this little red tangent thing there. Tan to the power of -1, right? That's the inverse of tan. That's what we're doing. This is the same thing as dividing by tangent. So I'm taking this inverse of tangent of 11 over 25 to find my angle, which is 23.75. So my angle, theta, is 23.75 degrees. You do that the exact same way for question B. This is going to be your opposite side. This is going to be your adjacent. This is going to be your hypotenuse, and your slope here is going to be the rise over the run. Sorry, that's not the rise over the run. This is the rise over the run. Your 14 would be your rise here. Okay, so for question 3, if you're ever unsure, draw yourself a nice diagram. A ski jump rises 3 feet over a run of 2 feet. So you have your skier here. We have a run of 7 feet, a jump of 3 feet, a rise of 3 feet, and then this is the ramp itself, right? So what's the length of the surface of the jump? That is this thing right here. That is your hypotenuse. So you take your a squared plus b squared. This is Pythagoras. I'm finding the length of a side, so it has to be Pythagoras. A squared plus b squared equals c squared. Substitute it in, right? I know c is my hypotenuse. So I'm going to leave that as this because that's what I'm trying to find. I know that these, it doesn't matter which one of these is a and b right now. So I'm just going to put 7 squared plus 3 squared. If you punch that into your calculator, you should end up with 58. So 58 is equal to c squared. I do not need c squared. I need to find what c is. So I need to take the square root of 58. So I take the square root of 58, 7.62 feet, right? It's a distance. So that's 7.62 feet. Perfect. The angle of elevation of the jump, that's this thing, right? That's this thing right here. So this one would just be tangent of theta is equal to opposite, which is 3, over adjacent, which is 7. So all you do here is take the inverse of tan, second function, tan, put your little fraction here of 3 over 7. That's going to give you your angle that you need, 23.2. 23.2 degrees, right? Make sure you keep that measurement there. This is theta. For number 4, a driveway rises 2.6 So we have our driveway here, right? This is the driveway. So it raises 2.2 feet from the street level and it has a distance of 5.8 meters. How long is the driveway? They're finding this thing here. So just do that a squared plus b squared plus c squared. This is your c up here, okay? For your angle of elevation, you are going to do the exact same thing that we did up here. 2.2 is your opposite. 5.8 is your adjacent. Put that into your calculator. I'll give you your answer. I'm going to skip past that. You can just check your answer. Now, number 5 is an interesting one. So we need to think about this very carefully. So a wheelchair ramp is being built to rise to a landing that is 2.4 meters above the ground. Building regulations say that the ramp can have a maximum rise of 2.5 centimeters per 30 centimeters of run. What is the total run of the wheelchair ramp? Okay, so let's really think about this. What do we know? What do we know? We know that I can have a 2.5 centimeter rise to a 30 centimeter run. I have a ratio here, right? I also know that the wheelchair ramp that they're building has 2.4 meters. And we want to know what the run of this ramp is. Now, a lot of people are going to forget that you need to convert the meters to centimeters, right? 2.4 meters is just 240 centimeters. Now all I'm doing is I'm figuring out what number they took 2.5 and they times it by. So 2.5 times some number gives me 240 centimeters. How do I figure out that number is? I figure out how many times 2.5 fits into 240. So 240 divided by 2.5 is going to give me my answer of 96. So this took 2.5 centimeters. It times it by 96 to give me 240 centimeters, which means I take this 30 centimeters times this by 96 to get my answer. So 30 centimeters times, I'll do it on here. 30 centimeters times 96. My answer is 2,880 centimeters. Now, this is not a really nice measurement to give you. If you gave this to an engineer or a construction company, they would laugh at you. You want to convert this to meters. To convert centimeters to meters, 100 centimeters is a meter, right? So divide it by 100. Your answer is 28.8 meters. So 28.8 meters. We're putting it back to meters because that's what the question originally had for our example here. So how long will the ramp be? So let's draw it out, right? So I have a ramp here. Here I have my person who needs the ramp. I know that it is rising a total of 2.4 meters. It tells me that up there. I know that the run, which I just figured out, is 28.8 meters. And I'm trying to find the angle of elevation. Or sorry, I'm trying to find how long the ramp will be. Sorry, how long the ramp will be, which is this thing right here. So then you just do a squared plus b squared equals c squared. So 2.4 squared plus 28.8 squared equals c squared. Take the square root of that. You have your answer, okay? Now for question 7 here, question 6. So there's a very steep section of a highway connecting Anaheim Lake and Bella Coola, BC. At its steepest section, it rises 900 meters over a run of 5 kilometers. What is the percent grade of this section? Okay, so it rises 900 meters over a run of 5 kilometers, which is 5,000 meters, right? So let's just get it into the same unit, get it into the same measurement. You can make this kilometers if you want as well. It doesn't matter. Get them in the same one. I've chosen meters just because. So I don't remember how to do this. Oh, you know what I'm going to do? I'm going to go up to my notes. So I'm trying to find how to turn distances into a percent grade. Oh, let's go find out. How do I do percent grades? I'm going to scroll up to my notes. Percent grade. To turn a slope, I have a slope. I have a rise and a run to a percent grade. Multiply it by 100. Okay, that's easy. Let's go back down. So to turn a slope, which is 900 meters over 5,000 meters into a percent grade, I just times it by 100. That's it. So 900 over 5,000. That's my arrow keys. And I just take that whole thing times it by 100. My answer is going to be 18. So this is equal to an 18% grade. Okay. This is a terrifying road, by the way. This is extremely dangerous. You are at risk of breaking your brakes if you take this, take that road. So just so you know. Okay, so let's keep going here. Question seven. So that water will drain properly, a patio attached to a house should slope downwards for about 2.5 inches for every 10 feet of run. Okay, here's what we need to do. We need to get these in the same units. If you don't know how many inches are in a foot, which is 12, by the way, we do know how many inches are in a foot, right? We know there's 12 inches in 1 foot. So 10 feet, so 10 times 12, I have 120 inches of run here. Cool. I have the same units. Perfect. Now I just need to find the slope. The slope, M, is equal to just rise over run, right? That's all it is. So I know what my rise is. My rise. Oh, shoot. I don't know what that is. Calculate the slope. Oh, the slope in this case is, so it should slope downwards. I see. My apologies. So M equals rise over run, right? So M is equal to rise over run. It tells me what my slope is, which is 2.5 inches. So all I'm doing is substitute in, right? So this is now my slope. This is my little M here. My rise is, I don't know what it is. But I do know that my run is 120 inches. So how can I figure out what to do here? Well, I can just take both of these and times both sides by 120. So if I times both these sides by 120, these are going to cancel out. And I'm going to be left with X all by itself. So I'm going to end up with X all by itself here. And so 2.5 times 120 is going to give me 300. Okay, so now I know what my rise is. So now my slope is equal to 300 over 120 inches. But technically your slope in this case is just 2.5 inches. So if you want to find the percent grade here, okay, well, how do I find a percent grade again? I don't remember. How can I do that? I'll look at my notes, right? So to turn a slope into a percent grade, which we now have, you multiply it by 100. That's it. So to turn a slope into a percent grade, I know what my slope is. My slope is 300 over 120. So I'm going to take that whole thing. So 300 divided by 120 and times that by 100. Oh, you know what? I realized I've done this whole thing wrong, so I do apologize. So I'm just going to quickly erase this. I've made it more complex than it needs to be, actually, because question A threw myself off. I was just looking at my notes for this. So I'm just going to erase all of this. I apologize. Okay, so just erasing all of this stuff here, because you can't have a percent grade of 250%. That would kill you. That's a wall. Okay, okay, so the slope in this case was, all I needed to do was get this into the correct units. But technically, my slope in this case is just like 2.5 over 120 inches. So the slope in this case is M equals rise over run. So I do apologize. I did this all wrong for you earlier. Rise over run. Again, everyone makes mistakes, right? My rise in this case, 2.5 inches, 2.5 inches. My run, 120 inches, right? That's it. If you calculate this out, you end up getting 0.1 16666, or if you want to turn it into a fraction, which you should, you end up getting 5 over 240. All I did was double this, right? Or this is also 1 over 60, which is technically the best correct answer. So my slope is 1 in 60, rise over run. For every 1 inch, it goes up or down, it goes 60 inches horizontally. So now I want to find the percent grade. I find the percent grade by taking my slope, which is 1 over 60, times that by 100, right? 1 over 60 times 100 is going to end up giving you, technically this is going to be 5/3, but we need to turn this into a percentage. So it's actually 1.67% is the slope of this thing. So it's a very minor slope. Okay, question 8. So one of the steepest railways in the world is the Lisbon tram in Portugal. In one section, it has a grade of 13.5%. Express this as a slope. Okay, so now it's a little bit different. Now we know the grade of it, and we want to try and turn that into a slope. Well, if it's 13.5%, remember, percent per 100, I can figure that out. So if I have 13%, it's just 13 over 100. If I have a decimal in here, though, 13.5% over 100, I can't have a decimal in a fraction. I need to times both of these by 10 to get 135 over 1,000. This is now a proper slope. I can simplify this whole thing, of course, to give me 27. I can divide these both by 5. Over 200. Your calculator has a way to simplify these, by the way. So that's it. That's the slope right there, 27 over 100. Now I want to calculate the angle of elevation. So now, using a slope, I need to calculate an angle of elevation. So let's look at what our notes say. Our notes say to turn an angle of elevation to percent grade, we need to use tangent of the degree times 100. Tangent of the degree times 100. What the heck does that mean? Well, in order to turn a slope into an angle, again, think about it like a triangle. Oh gosh, that's a bad triangle. Think about it like a triangle. I have my triangle here, right? This is the railway. Let's just pretend this. I know that I have a rise of 27 for my previous answer and a run of 200. Oh, I have a triangle here, right? I'm just trying to find the angle of elevation. Right here, this is what I'm trying to find, right? Looking up the cliff face. So how can I do that? Well, I'm trying to use sides to find an angle. I know I need to use tangent there, right? So tangent is equal to opposite over adjacent. My opposite is 27. My adjacent is 200. I know how to solve this now. So you put that in your calculator, you can get your answer and you'll be good to go there. Now we want to find out, well, what if the rise, what's the rise if the run's 15 meters? We know the slope. So let's figure this out. So I know, again, rise to run, right? Same thing as in a ratio here. It's 27 to 200. I go up 27. For every 200, I go horizontally. I do not know my rise here, but what I do know is the run of 15 meters. So I now have two things I know. I know I need to take 200 and times this by something to get to 15. How can I figure that out? 15 divided by 200 gives me 0.075. So I took 200, I times it by 0.075, and that gave me 15. So that means I can take 27 and times it by this to give me my answer, right? So the answer here is going to be I'm going to actually go straight to 2.205 because it's that close. You could do 2.03 if you want as well. But so it's actually going to be a rise of 2.025 meters. That's my rise. Now for question 9, kind of a tricky one here, right? So the pitch of a roof, pitch is the slant of the roof, right? That's this thing, is on a lean-to. The pitch of a roof on a lean-to that Deanna is building is 2 to 5. We know this thing here is a 2 to 5 ratio. If the lean-to touches the ground 4.8 meters from the base of the building. How high up does it reach? So we're trying to find this, right? We're trying to find H. So what do I know? I know that I have a 2-to-5 ratio of rise over run. I also know, I don't know what the H is, the rise, but I know the run is 4.8 meters. So all I need to do is take 5 and times that by a random something to get there. So how do I figure that out? Divide, right? Oops. So I take my 4.8, divide it by 5, backspace. 0.96. So I took 5, I times it by 0.96, which means I take 2, I times it by 0.96 to get my answer. 1.92. The answer here is going to be 1.92 meters. That is H. Now for question 10, what is the pitch on the roof of an A-frame building if its height is 3.6 meters and its width is 5.4 meters? So that's this thing, right? We're trying to find the pitch of this. Remember, pitch is expressed in the form of a ratio. So here's what we know. It's an A-frame roof, but this is technically what we call an equilateral triangle, which means that, or sorry, an isosceles triangle, which means that I know that this is going to be smack dab right in the middle. So what is half of this whole line? Well, 5.4 divided by 2. This line is 2.7 meters. Now, I'm trying to find the ratio of this, right? Well, I know the ratio is just rise over run, isn't it? It's just rise over run. So again, I'm only doing half the triangle, right? I don't care about this right half right now. I'm just trying to figure out just this half of the triangle. Rise over run. It rises 3.6 meters to 2.7 meters. That's the slant of it, right? Now I need to simplify this. I can't have a decimal in it. Oh, well, why don't I just times these by 10? That's going to get rid of the decimal, right? 36 to 27. Now I just need to simplify it. I can divide these both by 3, which is going to give me 12 over 9. I can divide these both by 3, which is going to give me 4 to 3. There is a 4 to 3 ratio here, which means this is the pitch of it. It's a 4 to 3. It rises 4 feet for every 3 feet it goes horizontally. So now question 11 is, if the roof of a tool shed has a pitch of 2 to 5, if the shed is 7 feet wide, what's the rise of the roof? So pitch is rise to run, right? I also know that I'm trying to find the rise of a roof, X, but I do know the run of it, which is 7. So I just took 5, I times it by a number to get the 7. You can figure that out on your calculator. It's going to be 1.4 though, right? Because 5 times 1.4 is going to give you 7, which means I take 2 and that I times that by 1.4. So my answer here is going to be 2.8 feet. It's a unit of measurement, and that's my answer there. Perfect. Okay. Okay. For the review, I'll just let you guys do that on your own. Check your answers. Ask me for help if you need to. Good luck.